Okay, hey Zach, this is hopefully going to help you here. I'm going to do this problem for a bridge that's given as shown. So what you want to make sure you understand here is that you have an ellipse. I'm going to put this little X here in the center to represent basically the origin. And what it is an ellipse that actually continues down like this. And so we can come over here and kind of look at it like this. Now, according to the formula, it's x squared over a squared plus y squared over b squared equals 1. That's the general formula for any ellipse centered at the origin, which we have here. Here's the origin. And so the distance here is a, and then this is negative a. And in this problem, if we come back up to our picture here, the distance from the center to the edge here would be 90 feet. So I'm going to come back and label this as 90. And then over here, this will be negative 90. And then for the B, we look at the distance. It's the vertical distance here. Now that vertical distance is going to be 60. So it's a little different. For the 90, we had to take that 180 and cut it in half. But here for the 60, it's just going to be 60. So this would be a y value of 60, and then down here negative 60. Now what I'd like to show you is that if you pick some values for x and y here, this equation is true. So I'm going to pick some arbitrary point on this ellipse just to show you that this equation is true. And I'm going to pick that point right there. That point right there has an x coordinate of 90 and a y coordinate of 0. And what you'll notice, oh, also I should point out that a is 90 and b here is 60. So if I rewrite this formula and I replace my x with 90 and I replace my y with 0, then what I would get is 90 squared over, now remember a here is 90, so I get 90 squared over 90 squared again, plus now y here, our y coordinate was 0, so it would be 0 squared over, now b here is 60, that comes from here, 60. All right, that's going to be our b. So we get our 60 squared equals 1. Now is this true? Well, this goes away, that's 0. 90 squared over 90 squared is 1, that's true. Now if you pick another point, like let's say you pick 0, 60, and plug it into this, then what would you get? I'm going to do it quickly. 0 squared, we already know a is 90, so 90 squared, plus b here is 60, but then squared over b squared, which again we said was 60 squared, and that would give you 1. This goes away, you get it. So I'm just trying to convince you that this equation is true for any ellipse. Now getting back to your question here, let me see, let me go back to one of these here. Yeah, something like this. Choose a suitable rectangular system. Find the height of the arc at a distance of 50 feet from the center. So if I go back here and I just imagine going from the center and I go 50 feet over, right? 50 feet. Oh, I went way too far. Because the whole way is 90, right? From here all the way is 90. So 50, I don't know, somewhere around here. Then what is this point? So coming back to our picture over here, that would be like going out to 50 and then asking, where are we here, right? Where is that point? So, well, what's the y coordinate is what we want to know, right? What's that? So I'm going to go to my formula. I know that x squared over a, which is 90 squared, plus the y coordinate squared over b, which is 60 squared, must equal 1. Now what I know right now is I know that when I'm at this point back here, when I'm at this point here, I know that the x coordinate here is 50. So I should be able to plug that 50 in here. Boy, I'm making a mess, aren't I? 50 squared, it's late, I'm sorry. 50 squared over 90 squared plus y squared over 60 squared equals 1. And then at this point, I think you know what you can do. You can square the top and bottom here. You move that over, subtract it, and then you multiply both sides by 60 squared, and then take the square root. I hope that this helps. If it still doesn't, give me a call. We can talk about it.